So the solution is given by x minus f dash of d. So f of d is d square minus 1, then f dash of d will be 2d. So 2d upon d square minus 1 multiplied by 1 upon f of d, which is d square minus 1, into v. V in this case is sin x. So as you can see, first we have to apply the operator of d square minus 1 to this sin x. Then we get some value. Then we multiply this value inside the bracket here and here. After multiplying that value, we again need to apply the operator of d square minus 1 and d. So in this case, we need to apply operator twice. So that's why we check whether this part is case of failure or not, so that we have to apply our operator only once. So in this case, if you see, we used to substitute d square equal to minus of a square. In this case, a square is 1, so we will substitute d square as minus 1. So in this case, if we substitute d square equal to minus 1, we will get minus 1 and minus 1, which is minus 2. So this is not a case of failure. So this equation is not a case of failure. So in this case, we can multiply this part inside the bracket. We will get x into 1 upon d square minus 1 into sin x minus 2d. This d square minus 1 and d square minus 1 will become d square minus 1 the whole square into sin x. So now here we are going to substitute d square by minus of a square. Here also we will substitute d square by equal to minus of a square. In this case, a is minus 1. Here, in this case, d square is minus 1. Here also minus 1. We will get x upon 1 minus 1 sin x minus 2d minus 1 the whole square into sin x. So this will become minus x sin x upon 2 and minus 2d minus and minus 1 and minus 1 will become minus 2, and the square of minus 2 is 4 into sin x. So this 2 ones are 2 and 2 2s are 4. I can take minus half common, so I will get minus half x sin x and d into sin x. D represent derivative, and derivative of sin x is nothing but cos x plus cos x. So this is the solution of this part. As you have seen, this is not a case of failure, and I have multiplied inside the bracket. Now again we are going to solve the same thing by not multiplying inside the bracket. So this is the final solution of 1 upon d square minus 1 x sin x, which is minus half x sin x plus cos x. So now we are going to again see this equation. So the solution is given by x minus f of d, which is 2 into d upon d square minus 1 into 1 upon d square minus 1 sin x. Now we are just solving as it is, like we are not multiplying the bracket. This bracket inside, we are not multiplying this term inside the bracket. So first we will solve for this. So in this we will replace d square by minus of a square. In this case, a is 1, so d square will be minus 1. So this part will become 1 upon minus 1 into sin x, and this term will remain as it is, which is x minus 2d upon d square minus 1. So this term will become minus half sin x. So I can take this minus half here, and I will multiply this sin x inside the bracket. So I will get minus half x sin x minus 2d into sin x upon d square minus 1. So now we have here, in the denominator we also have sin d square minus 1. Now again we will apply the same formula we used to apply here. So we will replace d square by minus 1. So this will become minus half x sin x minus, so d square will be replaced by minus 1, so minus 1 and minus 1 will become minus 2, and this 2 and this 2 will get cancelled, and minus sign will be multiplied here, so it will become plus d sin x. Now we will take the derivative of this, which will be minus half x sin x, and derivative of sin x is cos x. So as you can see, we will get the same formula, but here we have to apply the operator of d square minus 1 twice. This term sin x is very simple in this case, but when we see the complex problem where this sin x will be some different term in which it gets very complex to apply the d square minus 1 operator again. So that's why we multiply inside the bracket when it is not a case of failure. So 1 upon d square minus 1 x sin x is nothing but minus half x sin x cos x. So this part is nothing but minus half x sin x plus cos x. So the yp is nothing but minus cos x upon 2, and this minus sign I am taking inside, so minus x sin x upon 2, and minus cos, this minus will be multiplied here also, so minus into plus will become minus cos x upon 2. This minus cos x upon 2 and minus cos x upon 2 will get added, and we will get minus cos x, and this part will remain as it is. So this is our yp, and the final solution will be y equal to yc plus yp. And this is how we solve the problem on type 5. More such problems we will see in our next video, so stay tuned for our future lectures.